Hello and welcome back to the course on machine learning. In today's tutorial, we're talking about decision trees and the intuition behind them. All right, so you may have heard the term CART, which stands for classification and regression trees. And this is an umbrella term that encompasses two types of decision trees. And as you've correctly guessed, they are the classification trees and regression trees. And in this course, we're going to talk about both types, but specifically in this section, we're focusing on the regression trees. And I wanted to mention right away that regression trees are a bit more complex than classification trees, and that's why this tutorial is going to be a bit longer and it's going to require some additional attention. But nevertheless, we're still going to break this kind of somewhat complex topic into very simple, bite-sized elements of information, so it will all make sense, and towards the end of it, you'll be quite comfortable with regression trees. So let's get straight into it. All right, so here we've got a scatter plot which represents our dataset, so a dataset that has been given to us. And the interesting thing about this scatter plot is that we've got two independent variables, x1 and x2, and what we're predicting is a third variable, a dependent variable, which is y. And you cannot actually see y on this chart, and that is because this is simply a two-dimensional chart. It can only fit the two variables. Y is the third dimension, and if you think about it, it's like sticking out of your screen. That's where that dimension is, and this is just a projection of all the points on the x1, x2 plane. And so if I add the third dimension, it would look something like that. But once again, we can't see y right now. And the interesting thing is that we don't actually need to see y because we need to work with this scatter plot first for a little bit to build our decision tree. And then once we've built it, we'll return to y. Now, a quick point I wanted to make here is that I've seen decision trees explained with just one independent variable, so x1 or just x and y, and in that case, yes, you can just put x1 over here, and then y would go over here, and you would have a bit of a different kind of diagram, and you'd be able to explain it that way. But at the same time, I think it might not really drive the point home, and it can be a bit confusing when it's explained like that, although sometimes it is done. Nevertheless, I thought we'd go the full way, we'd do the full Monty, and we'd look at this problem with two independent variables because it'll be a more robust explanation. So it will make it a bit more complex, but it's definitely worth it in the long run because that way we'll understand the decision tree regression a bit, or actually, I would say quite a bit better. All right, so let's continue. We've got the x1 and x2. These are independent variables. The dependent variable, we cannot see it. It's the third dimension, and we're actually going to forget about it for a little while, right? So we're going to just forget about it because we need to work with this scatter plot to see how our decision tree is going to be created. So once you run the regression tree or decision tree algorithm in the regression sense of it, what will happen is your scatter plot will be split up into segments. And let's have a look at how an algorithm could go about doing that. So an algorithm would create a split over here, for example, at somewhere around 20. So it would basically split your diagram or your scatter plot into two parts. Everything that's less than 20, everything that's greater than 20 for the x1 variable. Then another split would happen here. So for all of the elements in this side, they would be compared to 170, greater or less. And then there would be another split here, and then maybe another split over here. Now, how and where these splits are conducted is determined by the algorithm, and it involves looking at something called the information entropy, and it is a mathematical concept. It is quite complex. So it basically means when I perform this split, right, is this split increasing the amount of information that we have about our points? Is it actually adding some value to our way that we want to group our points? And the algorithm knows when to stop is when there's a certain minimum for the information that needs to be added. And once it cannot add any more information to our setup by splitting these leaves. They're called leaves. So each one of these splits is called a leaf. By splitting these leaves, once it can't add any more information, then it stops. Or the algorithm could, let's say, stop when you have less than 5%. If you were to conduct a split, then you would have less than 5% of your total points in that leaf, and then that leaf wouldn't be created. So there are different variations or different options for that to happen. But like the most important thing is, of course, where the splits are happening. And if you'd like to learn more about that, you'd need to study a bit more about information entropy. We're not going to go into that mathematical depth right now. For us, it's sufficient to know that the algorithm can handle this and that it is finding the optimal splits of our data set into these leaves, and the final leaves are called terminal leaves. And then we're going to focus on the practical application of this algorithm, how and why we're using these decision trees and how this regression is going to work. All right, so hopefully we're on the same page. Let's continue. So we're going to rewind all of this a little bit, and we're going to create these splits one by one, and alongside we're going to actually start drawing our decision tree. So there's our diagram, brand new and fresh, and there goes our first split. So now we're going to start creating our decision tree. The split happened at 20, so let's start drawing. There is our first decision, and we have two options, yes and no. All right, so let's see what happens next. Next happens split 2. Split 2 happens at 170 and only happens for the points that are greater than 20. So that means you would check this condition, x1 is less than 20, meaning you check no, the answer is no, and then you check if x2 is less than 170. x2 is less than 170. Then a split 3 happens on the other side, and it checks if x2 is less than 200. Let's add that here, x2 is less than 200. And then split 4 happens at 40, and it checks if x1 is greater or less than 40. And split 4 only happens for the points that answered to split 1. They answered no, it's not less than 20, and to split 2 they answered no, it's yes, it's actually less than 170. So no, it's not less than 20. Yes, it's less than 170. And then this is where split 4 happens. X1 is less than 40. Yes, no. All right, so that's our decision tree. It's done, it's drawn. And so what happens next? What do we actually populate into those boxes? Well, this is where we need to remember about our dependent variable, the third dimension. And what we need to check here is, how are we going to predict the value of y for a new observation that gets added to our scatter plot or to our data set. So let's say we add a observation which has x1 equals to 30 and x2 equals to 50. It would fall somewhere over here, and 50 is somewhere over here. It would fall somewhere over here. So obviously it falls into this terminal leaf. And how does that information, so as you can see, by adding these splits, we've added information into our system. So how does that information that now we know that it falls into this terminal leaf, how does that information help us in terms of predicting the value of y for that new element that we're going to add? Well, the way it works is, it's actually pretty straightforward. The way it works is you just take the averages of each of your terminal leaves. So you take the average of y for all of these points, and that will be the value that will be assigned to any new point that falls in this terminal leaf. Same for this terminal leaf, same for this terminal leaf, same for this one, and same for this one. So let's have a look. Let's say the average for y here is 65.7. The average for y here is 300.5, 1023 here, minus 64.1, 0.7 here. So for that point that we just discussed with x1 equals 30 and x2 equals 50, the predicted value of y, the regression tree algorithm, would predict a value of minus 64.1. If it were to fall in any other terminal leaf, then that's what the value there would predict. So as you can see, it's actually pretty straightforward. It's very simple. It's just taking averages. But you do need to remember that we are working. The whole point of this exercise is to add more information into our chart, into our system, to better predict y. Because if you think about it, what was our other option? What is our default option? If the default option without running any machine learning on this data set is to just take all of the points and take the average across all of the points. And whatever that is, wherever our new point, the new element of data that is added to our data set, wherever it falls, we just assign it always that average for all of the points that we had existing previously. What we did now is we've split our diagram up into these terminal leaves. The machine learning algorithm has added information into our system. And so now we can more accurately predict the value or assign the value of y to a new coming element. And as you can see, now it's the average, not just across all of them. The average is taken in specific parts or segments of our scatter plot. And therefore it is, or it's supposed to be more accurate. That's the whole point of the regression tree. And now the last thing we have left to do is to add the values into our decision tree. So basically we just add those values in here. And now whenever we have a new value, what would happen is the algorithm would just go through these checks, and it would check where it falls and it would assign the value. And that's pretty much it. So the scatter plot is more for like visualization, conceptual purposes, so you can maybe drive some insights from there. But the core of decision tree is actually held here. And that's why the algorithm is called a regression tree. I hope you enjoyed today's tutorial, and hopefully we did break down this quite complex topic into some simple and actionable steps. And I look forward to seeing you next time. Until then, enjoy machine learning.